Error handling is a critical aspect of all web applications, and if not done right, it could lead into missing many critical errors and tons of repeated code that can be hard to maintain. So today I'm going to show you the right way to do error handling in your ASP.NET Core Web APIs. Let's start. So here I have a small web API that deals with some fictional game data and that has the typical endpoints for CRUD operations. So as you can see, we do have an endpoint for retrieving all of the games. We have an endpoint for retrieving one specific game via its ID. And then we have endpoints for creating a game, updating a game, and also for deleting a game. Right? And so the game data itself lives right now in this in-mem games repository class that I'm going to go into right now. This is a standard implementation of the repository pattern, but this is doing everything in memory just to keep things simple for now. And so you can see we have just 3 games, and then there's a typical implementation of the repository pattern right there. Right? So if we go ahead and run the server right now, so I'm going to use run.NET run, and then we go into my helloceptions.http file where I have prepared a couple of requests. I'm going to click on send request here, and then on the right side, you can see that we get the data for the 3 games that are available in the repository. If I hit the other endpoint, you're going to see that we received the data for just 1 game. So that's all good. But what we want to see is what happens when exceptions start trickling into the application, right? So I'm going to just stop my server for now. I'll close this and I'll close that. And so what we're going to do is just to temporarily modify our repository so that these 2 operations, get all async and get async, are actually throwing exceptions, right? Just to simulate what could happen. So we're going to just say here, throw new invalid operation exception. And then this is going to just say the database connection is closed, right? And so since we don't have anything to wait on for now, I'm going to just remove the async word over there, and then I'm going to just copy and paste that same line on the other method and remove the async keyword right there. Right? So since we are these 2 methods are throwing now, we should get exceptions anytime we invoke either games or games by ID. So I'm going to just start my server once again. Right, start server, and then I'll go into helloexceptions.http. I'm going to collapse this and then send request. And then as you can see on the right side, this time we do get a 500 internal server error, which is kind of the expected exception when unexpected things happen in your web API, where it really means that something really bad happened on the server side. It was not caused by the request, but there's just something going on with the backend, right? Which is expected at this point. And you can see over here that we have all of the details about the exception that will cause right now. If we open the terminal over here, we're going to see that we do have a bunch of details about the exception. If we can see there better, we're going to see that this data here is actually coming from what is called or is known as the developer exception page middleware. Let me actually highlight that better. Over the developer exception page middleware, which is the middleware that kicks in anytime that you get this type of exception in a development environment, right? So right now I am just running this code in my box. So by default, this is going to be the development environment. And so that's the reason why I'm going to be seeing all this data. Now, I don't want to be seeing this much details, of course, if this was deployed in production, right? And so what will we see if we were in a production environment, right? So this developer exception middleware gets injected by default when you are in development. But if we just go very quickly into our launch settings.json file over here, which allows us to provide some details for the current environment where we're running the application. In this case, we could modify the ASP.NET Core environment variable here, which controls this development or production environment setting. So I'm going to just switch this from development into production. So that's what you will get when you deploy this application into production. So with that change in place, let's see what happens now if I just go ahead and let me just collapse that. And then I'm going to run the application once again, and I'm going to go again into here, click send request, and let's see on the right side, we no longer have any of those details, right? So all we have is a standard 500 internal server error, no more details about what happened. And then if we see the logs here, we still see the logs that we were seeing before, right? So which is expected. So these logs are now coming directly from the web server from Kestrel. As you can see, the errors are coming directly from there. Okay, and so there are a couple of issues with this here because of course we usually want to provide a better login experience, right? We usually want to add some additional metadata to these errors so that later on we can troubleshoot the issue in a better way. that for the login side, but also on the response side, we don't want to just return this kind of an empty page into the client, right? We want to provide a little bit of information of that can help also troubleshoot from the client side. So what can we do about this? So let me see. Let's make sure we stop the server for now. And so let's close this and close that, and let's go back into program.cs. So there are a bunch of ways to deal with this. So the first way that I'm going to show you here is the typical try catch, right? That you would start with typically for this purpose. So what I'm going to do is just say here. So I'll add this try catch statement, and then I'm going to just move our code into the try block over there. And then what we want to do is say, okay, so we're going to be catching any exception that goes over here. And then we want to do a couple of things. The first thing is going to be that usually we want to log this somewhere, right? And so to do that, what you can do is just say app.logger, right? And then this is going to be logged as log error. And then here's where we can decide how exactly we want to log this. In our case, we want to say, okay, we're going to be sending over the original exception into the log, and I'm going to send it to the next line. Yeah, right there. And then we're going to provide kind of a friendlier message to the client. Well, not to the client, actually to the log line that we're going to store in our application. So this is going to be could not process a request on machine, right? And here's where we're going to kick in with the structured logging. So we're going to just say this is going to show as machine. And then we're also going to attach a trace ID so that it is easier to later correlate this error with the actual request that came into the application. So that trace ID is going to come from a trace ID element there that we're going to be injecting now. So now we're going to be saying as parameters to this log line, we're going to say for the machine, we're just going to be using environment.machine name. And for the trace ID, we're actually going to get that from activity. And then to use that, we're going to do control dot here, and let's just choose system.diagnostics, right? So this is going to be activity.current. And then this could be null, so let's use a question mark there, and then the ID. Right? So with this, we have a little bit of a nicer error message in our logs that clearly says that we could not process the request, right? So that deals with the issue of recording additional details in our logs. But we also want to return something meaningful to the client, like I said. So let me scroll down a little bit more. And then what we want to do is to prepare the appropriate response send back to the client. So for that, what we can do is just say return results dot and then here, of course, you could do just a status code and just say, okay, so I'll just return a 500 and that I'm going to be done with that. But that's not really a great experience for the client. So what we want to do instead is just say results dot problem, right? So this is going to prepare a problem details payload, which is a standard way to return errors into your clients, right? Which every client should be able to understand very well. So for that one, we're going to start adding a few elements here. So first thing is going to be our title. So it's going to be the title like this. And so for this one, we do want it to make it kind of friendly. So we're going to just say, well, we made a mistake, but we are working on it. All right. So that's going to be the title of the error. And then we want to provide a status code, of course. So this is going to be status codes dot status 500 internal server error, because this is still a 500 error, right? And finally, we also want to provide that same trace ID as part of this result, right? And to do that, we can use the extensions element over here, which is kind of a dictionary of elements where you could put a bunch of things. So I'm going to just say new dictionary, okay? And this is going to be of type string and object, nullable object, all right? And so in this dictionary, and let me scroll down a bit over there, we want to include just one element for now. Is going to be trace ID. All right, and this trace ID is the same value that we got over there. So let me just copy the activity ID from there. And then this is not a colon, it's just a comma, of course. And then I'll just close this, right? And so one last thing that we have to do here is to make sure that the return type is standard across both the happy path and the error path, right? So right now we're returning a results object on the exception side, but on the happy path, we're just returning the list of games. So we have to modify this so that we also return something that is an actual result object here. So we're going to say results.OK for the case where we return the actual data, like that. And let's make sure that the await operator actually goes when we invoke the getAllAsync method, like that. Okay, so with this code here, what you can see is that anytime this getAllAsync method fails, we're going to catch exception, we're going to log it in a nice way into our application, and then we're going to be returning this nice payload back into the client, including a nice trace ID to keep track of what's going on there. So let's see how that goes. Okay, so I'm just going to restart my server over here. So I'll do .NET run. All right, and then I'll go back into helloexceptions.http. I'll click on send request, and as you can see, let's look first at the client side. So in the client side, you can see that we still get the 500 internal server error, but now we are getting a very nice payload of error details over here, as you can see. So this includes the standard type of error, it includes the title, it includes the status, and it even includes the trace ID, which, like I said, is going to be super useful for keeping track or correlate this error with any errors that we have in the database, so that the application developers can investigate what's going on. And then that's a very nice response for the client. And also, as you can see, on the server side, we do have the exception now being logged directly by our application, and it does have the expected payload over there. Could not process a request on machine. Here's my desktop, and then here's the trace ID, right? And besides, we also have the exception, the stack trace of exception right there. We can see the actual exception over here. So that is a very nice experience and a very nice way to handle your exceptions for this specific endpoint. Okay, and so yeah, we stop the server. Now, if we go back into program CS, we'll say, okay, so that's good. So we have figured the issue or handled the exception properly for this one endpoint. But now we have to deal with the same problem for every other endpoint, right? So now we have to deal with the same thing for map get, for map post, map put, map delete. All of these could be failing in a similar way, right? And so we have to do something to properly centralize this code here, so that it only has to be written in one place, and we make sure that we always catch exceptions and report them properly the right way. And so how to do that? So here's where we can take advantage of one thing called middleware in ASP.NET Core. And so the middleware is nothing more than a piece of code that can execute between the moment when the request arrives into the web server and the moment when that request actually arrives into your application, right? So between the web server receiving the request and your application getting the request itself, there can be, and there is already, some code executing as part of the standard ASP.NET Core pipeline, and you can add your own middleware at that point to deal with whatever happens before or after the request is handled by your code. And so let's see how we can implement a middleware to kind of centralize this error handling. So what we're going to do is just go a little bit up here, and then we're going to be using this app object here, which is of type web application. And on this one, we can actually just use a very simple method to add kind of a lambda function to act as our middleware. So what we can do is just say app.use. Okay, and here we're going to introduce our async context and then next method over here. And then this is going to be just like that. So on this lambda, context here represents the HTTP context, which has all the information about the request that is coming into your application. And next represents the next function that's going to execute after this middleware, which typically is going to be just your function, right? Like in this case, your get function over here, okay? Or could be another middleware too, right? So by putting code here, we can do the following things. So we can just add our try catch block here. So let's do try. And then what we want to do in the try block is to actually just let the next request go in, right? So we want to say, oh wait, next context, right? We just let the request go in, and if there is an exception, right? So we have this catch block over here. That's when we can go ahead and do something about that. And so in this case, of course, what we want to do is just grab that code that we have down here, right? So copy that code. I'll just paste it in this block over here. And then just as before, this is going to take care of logging the error into the logger, right? Which could be configured to go anywhere really you want. And next, we want to just return the actual problem back to the client. To do that, we don't want to do return anymore. What we want to do is just say await resolves.problem. And then after we have defined the problem that we want to prepare, what we want to do is just, instead of doing this semicolon, we want to do dot execute async. And then we send the context right there, just like that. All right. So as you can see, the code is pretty much the same. It's just that now it is running as part of an actual middleware that should execute anytime any request comes into the application. So now what we can do is actually get rid of all of this exception handling code that we have in games. So we're going to get rid of all of this stuff, right? So going back actually to the original implementation, as you can see, super simple. And then let's see what happens when an error trickles into the application. So I'm going to just do .NET Run, and then go back into hello exceptions. I'll click on send request. And once again, I'm getting the exact same experience from the client side, right? With the type, title, status, and trace ID. And if we see the console over here, we're going to see that we have all the details about the exception, like right here, and we have the stack trace, we have everything that we had before. So exactly the same experience, but now it is centralized. So this means that if now I try the exact same thing with my other endpoint, my get by ID endpoint, click send request, and I'm getting exactly the same experience without having to write any additional error handling code for that second endpoint, right? So I'm getting the exact same errors and the exact same thing in my logs down here. Now that is all good, but if we go back into our program CS, so let me close this, stop the server, close that, and let's go back into program CS. The only problem with this right now is that, of course, it's just too much code for a program.cs, right? So having a Lambda function just like that over here is not looking great. So one way that you can improve this is by writing what is known as an actual proper middleware class. Right, so let me show you how that goes, because this is the most typical approach that which I have seen so far in other teams for error handling. So let me go to my Explorer. What we're going to do is just create a brand new class over here. Let's call it global exception middleware. All right, and so yeah, let's just collapse this, and so let's convert this into a file scope namespace. And then in order to make this actually act as a middleware, I'm going to remove that, what you have to do is the following. The first thing is that we need to capture that next delegate that we were dealing with before, but as part of the construction of this class. So what I'm going to do is just declare my private read-only request delegate. Let's call it next, just as before. And then the other thing that we're going to need here is of course the logger, right? We need a logger instance in order to be able to log into the whatever we want to log this stuff. So let's also add that read-only ilogger. All right, so this is going to be of type global exception middleware in this case, logger, and then we want to add both of these into a constructor. So I'm just going to do generate constructor with the logger. Let's also add the next element. Okay, so both them are received now into our constructor. Okay, just like that. And then by convention, what you're expected to do is to implement one very specific function into this class so that it can actually act as a middleware. So that function, and let me scroll down here, has to have this signature. So public async task, invoke async, and then you're going to receive here the HTTP context object, HTTP context. Right, and here where you're going to have the actual code for invoking the next delegate and also for handling any possible errors. Just notice that there's nothing here telling us that this is the exact signature that we have to implement for this to work, right? So if this is a standard class, it is not implementing in any interface or it's not inheriting from any class. So there's nothing here, is all by convention, right? So you have to be very careful about this. Now, what we want to have here is pretty much that code that we had before, right? So let's copy this code. Okay, so I'm going to copy this from program over here. And in fact, let's copy the entire thing, including try catch, right? So that's really what we want to do here. So let me just copy the entire thing with the try catch, just like that. All right. And so, yeah, so in this case, we decided to name this HTTP context. So let's just name it like that. This should be context, not context. Yeah, just like that. And then we're going to just say here, since we have our logger variable over here, we can now say logger.log error, and then we will do control dot here to import system diagnostics, just like that. And then we have results as problem, execute async, and then finally we want to do HTTP context, just like that. All right. And so that's pretty much what you need to do to implement your global exception handler middleware, right? And so as you see, it's the same idea. Now you just invoke the next delegate, and if something happens, you log the error, and then you return the proper payload back to the client. Now, how do you use this middleware in your code? Well, what you want to do is just go back into program CS in this case, and then instead of doing all of this stuff here, what you want to do is just say, I'm going to delete this. Okay, you just want to say app.useMiddleware, okay, and then we are going to put global exception middleware, just like that. And I'll do control dot here so that we can use the hello exceptions namespace right there. Okay, so now with just this one line, we are able to configure the global exception middleware for our application. So this time to be able to see actually things going in action, I'm going to just put a breakpoint over here. Let me put a breakpoint right here, and then let me put a breakpoint right here so we can see what happens. And I'm going to do F5 in my VS Code project here. Okay, so the debug operation starts, and now I'm going to send a request to games. And as you can see, we're about to invoke our code, right? We're going to invoke the code, and actually can put a breakpoint in program. So let me see if I can put a breakpoint over here. We're going to invoke the get all async method. Okay, and so I'm going to hit play, and as you can see, we hit the endpoint. Just after going to the middleware, we now hit this endpoint, and then if I keep going, of course, the exception happens. We hit log error now we are inside the global exception middleware, and then I'll just step over to the next one. We're going to report the problem, and then I'll step over. Okay, if I hit play now, we're going to get, again, on the right side, we can see that we get the same thing, right? The same kind of response, and then we should have kind of the same thing in the logs down here in the console, right? So same idea, but this time, and let me just stop debugger now, this time it is nicely centralized into this global exception middleware class, and our program CS is much cleaner this time. Okay, now like I said, there are still some issues with this because if you see, you could make mistakes while implementing this class, right? So if you just don't implement exactly this name here, it is not going to work. And then another issue is that you could, there could be some other things happening that you don't have control over here, right? For instance, it could be that by the time that your handler comes into play, and let me collapse this for a moment, the response could have already been started to being sent back into the client, at which point you cannot really prepare a different response by doing this thing that we're doing over here, right? So in that case, it's just not going to work. So it's a little bit error prone, right? There are certain scenarios, and certainly you can find a proper implementation of this somewhere in the web to try to make sure that this works properly all the time. And like I said, this is a typical implementation that I have seen in many places, but luckily these days, there's even a better way to do this, so you don't have to fall into those kind of corner cases and have a very solid implementation. So let me show you how to do that. So if we go back, let me go back into my Explorer view, what we're going to do is just to create now an extension methods class, right? So let's do new C# class. This is going to be called error handling extensions. Right, so this all we're going to put here is just one method that's going to be an extension. Now this class has to be static, and let's make it so that this is a file scope namespace, and it's going to remove that. And then what we want to do here is to implement just one method that's going to be called public static void, and you can call it any way you want, really, it doesn't matter. I'm just going to call it configure exception handler, right? And this is going to extend the application builder class. Let's call it app. And what we're going to do here is just use app to invoke the run method so that we can invoke or execute another delegate, which is going to have the signature of async context arrow function. Let's define the method body over there. Okay, and then here is where we're going to actually implement our logic for handling the exception directly, right? So we don't have to be dealing with before or after. This is when the exception happens, this is what we're going to do. So here we have to do a couple of things before actually handling the code. In this case, we have to figure out, well, where are we going to get things like the logger or the exception from in this case? So the logger we can get actually from the registered services from the service container. So to do that, what we can do is just say var logger equals context request services, and then get required service, and this is going to be iLogger of, in this case, class program, like that. Okay, so that's going to retrieve the instance of the logger that has been registered for program right there. Okay, and then the next thing is going to be the exception. So to get the exception, what you want to do is to do the following. So exception details is going to come from context.features.get, and then UseExceptionHandler feature. All right, and so let's do control dot here so that we can import Microsoft ASP.NET Core Data Diagnostics, just like that. And then we can do var exception equals exception details, and this could be null, so we'll do a question mark that error, just like that. So now we have a logger, and then we have an exception object available for our code. And with that, we are pretty much ready to bring in that code that we had in the global exception middleware. We can now go ahead and do the following. So I'm just going to copy all of this code from global exception middleware into our brand new implementation, paste it here. Okay, and then it's going to be very similar, just that the variable for exception is named exception now. For activity, we'll do control dot and import system.diagnostics. All right, and the variable for the context is just going to be named context in this case. And then, yeah, that's pretty much it. That's what you have to do to implement your your extension for error handling. As you can see, it is kind of the same body, but it's much smaller because we don't have to implement an entire class here, and there's nothing being done by convention here. This is an actual typed way of defining your extension. Now, where do we attach this extension, right? So now we want to go back into program CS, and here where before we were calling use middleware, what we're going to do is just say app.useExceptionHandler, okay, and then here we're going to be receiving an exception handler app object here, in which we are going to invoke, as you can see, exception handler app. We're going to invoke configure exception handler, just like that. Okay, so this UseExceptionHandler method is the one that's going to be in charge of taking care of invoking our handler anytime an exception happens anywhere in the application. All right, and so if we try this out now, so I'll do Control J, let's go back into our terminal, and then I'll just delete this, and I'll do run. Okay, that runs application. I'll collapse this, and then we're going to go back. If you close a few things over here, send request, and as you can see, same experience, same error, right? And same thing in the console down here. We're getting exactly the same thing, but now we are doing it the right way, right? Now, the only thing here that still is we want to kind of improve here, and this is kind of a decision of the implementers of this built-in exception handler, is the fact that that handler, the one that comes with ASP.NET Core, is already logging the exception for you, right? So you can see this first section here, this entire first section is not our login. This is the login directly from the exception handler middleware that comes with ASP.NET Core. Our login comes down here, right? Here where it says program 0 could not process a request, something, and then comes the exception here. Okay, and so I mean this could be fine, but I don't like to have the exception duplicated twice like that, right? So what I like to do for this is just to somehow mute the other exception that's been sent by default by the exception handler, and just keep my own one, right? So how can we do that? How can we mute that to clean up things a bit? So what you can do is, let me see, yeah, we stop this. Let's go to appsettings.json over here, appsettings.json. What you want to do is just to add one section here, and I'm going to paste this just to not mistype. What you want to do is just do the following. So you're going to put a section under logging, log level. You're going to add Microsoft ASP.NET Core Diagnostics exception handler middleware, and you want to put none. By doing that, you are pretty much turning off all of the logs or events that are coming directly from that handler, so that your one can take over completely. So if now we try this once again, run, and so we hit the endpoint, you can see that now we only have one error in the logs. So we have info, and then just our own fail, and there's no more errors over here. There you go, global exception handling done the right way, and well, I hope that was useful. And if you found this interesting, please check out other videos on my channel where I cover many other topics essential for professional .NET developers. So for now, thanks for watching, and I'll see you next time.